Okay, so Ben motivated some improvements to our factorial here. So here's what we've done. So the first thing we did was we imported a package or a library. I forget exactly what Java calls these, but probably a library. So we're importing the library Java math big integer. And what this does is that dynamic memory allocation thing I was talking about. So these are now objects, right? And they take a string argument that's a number. So here we're declaring a new big integer n that we're starting at 1. And we're declaring another new big integer called r that we're starting at 1. And we're declaring a big integer 1 that we're starting at 1. And we're going to leave at 1. Right? And then we've got some window size stuff. I made the window super duper wide so we could see the result. Otherwise, that's the same stuff. It's just black text centered up with sizes. And then in our draw method, we've changed some stuff. So we're going to draw over the background, right? And then we're going to print out text, and we had to do the toString method to our big integer to get it to actually print out. Because if we don't have that, processing yells at me saying that it expects this thing to be an integer, not an object. Why doesn't it know how to print an object? Yeah, but why doesn't it know how to print R just as an object by itself? Like, why wouldn't you want text to be able to take objects? Like, what are examples of objects that we've used in the course? Yeah, Chris's grow balls are an object, right? What the hell does it mean to print a grow ball? Yeah, exactly. Like, how do you feed an apple into a printer, right? Like, this is going to make some text on the screen. I don't know how to make something that has a bunch of attributes into text for the string, or for the screen, unless it has a, yo dude, this is how you print this thing, method in it. Which someone was convenient enough to have put in there. So we have a toString method that we're calling on the object R.
Technically, all Java objects automatically have a toString method. It's just until you declare it, it's completely different.
Oh yeah, of course it'll put out the like machine code for all the storage or some bizarreness.
It's storage position if you don't declare the toString.
Okay, cool. So yeah, that makes sense. And then this is just where we're putting it, and then we have n, and at each stage what we're going to do is we're going to make n equal to n and add 1 to it. Right? Like, we're just going to make the number we're outputting 1 bigger. Or, sorry, that's not the number we're outputting. That's going to be the number I multiply by. And then at each stage, I'm going to increase the result, right, the thing I had before, by multiplying by n. Why don't I need the factorial thing here? Like, why am I not using the factorial method here? Yeah, I'm kind of keeping track of it in here, right? So this is going to print out all the factorials up to something. I couldn't use this to figure out what the factorial for 75 was without counting very carefully and watching the screen. You guys see that? Yeah, I could maybe get it to stop when it hit 75 or something. Right, when capital N hit 75. But I'd have to, like, figure out how to compare big integers to regular integers, and that would be a little weird. Does that make sense? Okay. So, now if we run this, this should continue until the computer, what? Yeah, until either the CPU or the RAM are full, in which case this will stop working. Right? Why does it keep adding lots of zeros? You guys see that? Where are all those zeros at the end coming from?
Multiplying by 10, 100.
Yeah, every time there's multiplication by 10 or 100 or multiplication by 2 times 5, right? Or 25 times 4 gives you 2 more zeros, right? So there's lots of ways to get zeros. And they're not going to go away, right? Because there's still a factor of 10 in there.
Yes.
And I'm kind of psyched that this isn't starting to bog down yet. I sort of expected this to bog down.
The reason why is because it's being held as a stream, so it's gonna go pretty far. Yes.
Yeah, let's see. So we could actually figure out how far this is possible to go, given that this computer has 16 gigs of RAM in it, and probably it needs one of those to run Windows. So there's 15 gigabytes of RAM left over, and a byte is 8 bits, and a bit is a number that's either 0 or 1, right? So we could maybe just, like, ballpark this thing by doing some kind of basic arithmetic. It's taking longer to compute now. You guys have noticed the frame rate is not quite what it was. Every once in a while it'll, like, bog down. That's wild. Super cool. Work, Ben. Oh, let's take the frame rate up. That'll be fun.
60. Should we also print N so that we can...
Yes.
Oh, God. Yes.
That's fun. It should be noted, this is a horrible way to make an animation of numbers scrolling. Right? This is like the most memory intense way to make this picture you could.
It's starting to slow down a bit.
Yeah, I would imagine it'll slow down a lot eventually here. Actually, let's look. This will be fun. Let's see.
Oh, yes.
Sorry, I gotta give it a second to catch up here. Let's see. Okay, so currently, right, we're using, so we're using like 3 gigabytes of RAM, 4.5. Yeah, because I'm recording, I've got Chrome open, I've got processing open, I've actually got a Windows command shell open, got a couple of sketches open, and the task manager itself consumes a little bit of RAM. Right? Like, so it's no surprise I have actually a fair bit of RAM in use. So let's just push play on that and see what happens. So my CPU usage spiked to 40%. My RAM has not appreciably increased yet. Yeah, so it took roughly 200 megabytes of RAM to render the window itself. You'll see that the processor's kind of spiking every once in a while. Yeah, basically that's just when the numbers become inconvenient, right? And the algorithm for multiplication takes another step or two if the numbers are kind of mismatched. Yeah, for sure. Like, I'm actually super, super impressed that this isn't bogging down really, really fast. If you had run this on the very first computer that my family ever owned, it would have taken like 4 loops before it would have started to bog. I'm actively astonished that this isn't consuming all of the everything.
It's been stable at 30 since the beginning, and it's bouncing between 40 and 45 for the CPU. I'll open up 5 more. And it's spiking.
Yeah, that would be another way to burn a lot of processing, right? If we opened up another one. It should be noted that with modern parallel processors, some of the time raw code that you write won't run in parallel. So this may, I'm not sure actually how processing does this, but this may have only allocated to half or one of the cores of the CPU anyway, right? So if there's a 4-core CPU in this thing, it's possible that only a quarter of the CPU is going to be allocated to doing processing stuff anyway. Does that make sense?
It should show you on the CPU tab if there's multiple cores.
I would have.
2 cores, but normally it splits up the cores usually.
Yeah, normally you'll have a CPU 1 and a CPU 2 in this feed. I'm sort of surprised that I'm not consistently hitting 50% at least, because I would have thought this would grab all of one of the processors, and then the video recording would be on the other one. But maybe it doesn't take as much as I think it does. Yeah, it's been consistently over 50 since I went to the CPU tab, so maybe looking at the CPU tab. Right, and this is a funny example of recursion, right?
That was a no-bueno number right there.
Yeah, that's interesting. I wonder what that is.
Spiked to 100 for a second there.
Yeah, I don't know what that was. The Wi-Fi also spiked to 100 at basically the same time. You guys see that? So that was probably some other... Yeah, or I got an email or something, right? So, cool. I really actually can't believe that this isn't fully bogged. That's really cool. Alright, cool. Okay, so before it goes away, we were watching the processing run, and then I closed it, right? And the CPU dumped, right? Down to 10% usage. And then I stopped the video, and then it spiked again, right? So this part here was the processing running, and then this was the video recording thing, analyzing the audio track and kind of storing things up. And now this is the baseline. This is baseline of sitting there, and then I started the recorder again, and then this is the baseline to record video. Right, so we can see that the difference between what I'm using now, like 10 or 12%, and the 40 or 50% I was getting before, seems like all of that was due to processing. So that's probably one whole core basically allocated to doing processing.